Everyone, welcome to another video. This one is going to be about triangles and specifically the sides and the angles of different types of triangles. So what we're going to do in questions 1 to 3 is classify the triangle by its sides and its angles. So we have 3 different names for triangles based on their sides. They are scalene, isosceles, and then equilateral. Okay. Scalene is when all the sides are different lengths. Okay. Isosceles is when 2 of the sides are the same length. Just write 2, same. And then equilateral is when all 3 sides are the same. Okay, so 3 sides the same. All right. As far as angles are concerned, we have, I believe, 4 different ways of naming a triangle based on its angles. There is acute, obtuse, right, and then equiangular. Okay. So an acute triangle is when all 3 sides are acute. Sorry, all 3 angles are acute. 3 acute angles. An obtuse triangle is when we have 1 obtuse angle. A right triangle is when we have 1 right angle. And an equiangular triangle is when all 3 angles are the same. 3 angles that are the same. Okay. All right, so if we look at triangle number 1, we see that we have a very long side, a short side, and a medium side. So all sides are different, so it's going to be scalene. And then we also see that there is an angle that is obtuse, that's bigger than 90 degrees. Right, so this triangle would be a scalene obtuse triangle. Triangle number 2, again, we see a long side, a short side, and a medium side. So they're all different lengths. So we're going to automatically call this one scalene. And then as far as the angles, like this one is acute, this one is acute. This one, it sort of looks like it's a right angle. I mean, I can't tell for sure. So let's use a tool. Let's use a protractor and see. And at least to the naked eye, that looks like it's 90 degrees. All right, if I line things up. Okay, so let's just go ahead and say that that is a 90-degree angle. And so the correct name then would be a right triangle. Okay, so this is a scalene right triangle. This was a scalene obtuse triangle. This one here, the next one, number 3, we can see the tick mark. So we have 2 sides that are the same length. Right, so that's isosceles. And then let's see, the angles, that's acute, that's acute, that's acute. All 3 angles are acute. So this is an isosceles acute triangle. Right, question number 4. So we have triangle ABC, and basically we have the coordinates of the vertices. We want to classify it by its sides and then determine whether it's a right triangle. All right, so to help me do this, I'm going to switch my screen share. And let's just go ahead and use Desmos. All right, so the points were 6, 6, 9, 3, and 2, 2. Let me try that again. I don't know why it's Okay, so it was 6, 6, 9, 3, and 2, 2. All right. And then let's go ahead and create the sides. So I'm just using the segment tool to form the sides here. Okay. All right, so the directions said classify this triangle by its sides. So we have a long side, CB, we have a short side, AB, and we have a medium length side, AC. All right, so the three sides are different lengths. In fact, I believe we could verify that using Desmos. Okay, yes, so 7.1 units, 4.2 units, and 5.7 units. So all three sides are different lengths. This is a scaling triangle. Okay. Right, the next question said determine whether it is a right triangle. Okay. So this angle for sure is acute. This angle for sure is acute. This angle looks like it might be 90 degrees. It might be a right angle. One way we can check for that is we can compare the slopes of these two sides, right? If these slopes are opposite reciprocals, right, that would tell us that that is a right angle, that it's that they meet at a perpendicular intersection. So let me use my annotation tool. Okay, so let's look at this side here. And let's find its slope. Okay, so the slope is the rise over the run. So that's down 3 and over 3. All right, so -3 over 3. So that has a slope of -1. All right, let's look at the other side, this one here. All right, so the red side has a slope of, let's see, rise over run. All right, so rise is 4, run is 4. So that's 4 over 4, which is +1. Okay. So these two slopes, right, they're opposites. One is positive, one is negative. They're reciprocals. The reciprocal of 1 is just 1. Right, so these two slopes are opposite reciprocals. That means that this is a 90-degree angle. Okay. All right. So yes, this is a right triangle. Here's just some additional evidence. I know we can measure angles, yep. So let's measure that angle there, and yes, GeoGebra says that, yeah, that is a 90-degree angle. All right, let's go back to our document. Okay, so that was question number 4, and we just did that using GeoGebra. All right, number 5, let's find the measure of the exterior angle. So the exterior angle is that one right there. All right, well, I've got a triangle here. And so one of the most important things in this lesson is that the sum of the 3 interior angles of a triangle is equal to 180. Right? So let me just call that x for now. Right? And I can say that x plus 53 plus 53 equals 180. Okay, that's going to be 106. So x plus 106 equals 180. Okay, if I subtract 106 from both sides, then I would get x, the third interior angle, is equal to 74 degrees. Okay. So that is now 74 degrees. Okay. Now, I was trying to find the exterior angle, but you can see that the exterior angle, the one in pink, forms a linear pair with my third interior angle of the triangle, right? So the pink angle and the green angle are going to add up to 180. So these two angles here sum to 180, right? So the measure of angle 1 plus 74 degrees is equal to 180. So if we subtract 74 from both sides, we get that the measure of angle 1 is equal to 106. Okay. Now that number should look familiar because 106 was the sum of the other two interior angles. Okay. And this is one of the theorems about the angles of a triangle and the exterior angle. Okay. So it turns out that in general, the exterior angle of a triangle is the sum of the two non-adjacent interior angles. All right. So we're going to use that now to help us answer question 6. Okay. So the exterior angle is this one here. All right, and it's going to equal the sum of the two non-adjacent interior angles. So the green angle, the sum of the green angles is going to equal the pink one, right? Or I should say the measures of the two green angles combined will equal the measure of the pink angle. All right, so let's start with 40 here, plus 5x plus 15 equals 8x minus 5. Okay. All right, I can combine some like terms, so that's going to be 5x plus 55 equals 8x minus 5. Let's see, subtract 5x from both sides, and then I'll have 3x over there. Add 5 to both sides, and then I'll have 60 over there. Okay. Now it's just a matter of dividing by 3, and so we get x equals 20, okay, which isn't the answer. This is not 20 degrees, right? 20 would be acute, and we can clearly see that that pink angle is obtuse. So what we need to do is we need to substitute 20 as the value of x. Okay, so 8 times 20 minus 5, that's 160 minus 5, so 155 degrees. Right, our last question here says, in a right triangle, all right, let's highlight here. So we have a right triangle. So that means there's one 90-degree angle somewhere in that triangle. The measure of one acute angle is twice the sum of the measure of the other acute angle and the number 30. Okay. Find the measure of each acute angle in the right triangle. I'm just afraid I'm not going to have enough space, so I just grabbed a Post-it. All right, so let's just kind of draw a generic right triangle. So that's 90 degrees. And so let's see. Measure one. So I guess my initial thought is, okay, so let's call this angle x, right? So this is going to be my other acute angle is going to be x. Okay. And then now I need to create an expression for the third angle. Okay, so I've got a 90-degree angle. I've got this other acute angle, x. And then so this acute angle here, according to the description, is going to be twice the sum. Okay, so twice the sum. And the sum is going to be the measure of the other acute angle, x, and the number 30. Okay, that's my interpretation. Okay, twice the sum of x and 30, right? X being the other acute angle. Okay. All right, so I've got a 90-degree angle. I've got an angle represented as x, and then I've got another angle represented as 2 times the sum of x and 30. Okay. Now, what do I know about all three of the angles? Well, because it is a triangle, they have to add up to 180. So I could write 90 plus x plus 2 times the sum of x and 30 equals 180, right? Angle 1 plus angle 2 plus angle 3 is a sum of 180. All right, let's do a little distributing here. Okay, 90 plus x plus 2x plus 60 equals 180. We can combine like terms. That's going to be 150 and 3x. So 3x plus 150 equals 180. Okay, subtract 150, and you get 3x equals 30. And then divide by 3, and you get x equals 10. Okay, so that is our magic number. Okay, it's not an angle measure. Well, yeah, actually it is. It's that angle measure. So let's go ahead and plug 10 in there. So that's going to be 10 degrees, and then we'll plug 10 in here. So we get 2 times 10 plus 30. That's 2 times 40, so that's 80 degrees. All right, so the measures of the three angles of this triangle, 90 degrees because it was described as right. 10 degrees, that's one of the acute angles, and then 80 degrees is the other acute angle. All right, thanks for watching this video. If you have questions, save those and I'll try to answer them in our next Zoom meeting.